whenever we call the lock method by using the reference variable of reintrent_lock class. Then the thread which is executing the l.lock statement may or may not get the lock. If a thread is unable to get a lock, then that thread waits in a queue for the lock. In this video, we are going to get the information about such queues. Namaste everyone, I am Gyan and you are watching the session 20 of Java and Web, multi-threading in Java. In this video, we will learn about the hasQueued threads and getQueuedLength methods of reintrent_lock class. The method hasQueued threads is a public and final method of the class reintrent_lock, which returns boolean. The method hasQueued threads checks do anyone is waiting for the lock. If yes, then return true. If no, then returns false. As we have already discussed, the threads which are not able to get the lock in the first try wait for the lock in a queue. The queue is FCFS based queue. FCFS means first come, first serve based queue. That means the thread which got the first position in the queue will get the lock first. Here in this case, we have a Java file check.java. In check.java, we have the class check. In the class check, we have the method main. The method main throws interrupted exception. In the method main, we are creating a new object of type reintrent_lock, whose reference will be stored into the reference variable L. Then we are collecting the name of the currently executing thread, that is the thread main. So the reference of the string main will be stored into the reference variable name. After that, we are creating an array of type myThread class. The class myThread extends thread. That's why here we are going to create 15 new threads and we are starting all those threads. We already have created and executed such programs in the previous videos of this session. Then after, the thread main is checking, is there waiting threads present in the queue of the reintrent_lock object whose reference is stored into the reference variable L? If yes, means if threads are waiting for the lock, then hasQueued threads method will return true and the while body will execute. In the while body, we are printing IM, the name of the currently executing thread, that means main. IM main is some threads waiting. Then after, we are calling another method l.getQueueLength, means we are counting the number of threads which is waiting for the lock, and this method will return the number of threads waiting for the lock. If 10 threads are waiting for the lock, then this statement will print IM main is some threads waiting. Then here it will print 10. After printing such information, the thread main will go for a sleep for half seconds. Therefore, after each half second, the thread main is printing number of threads waiting for the lock. Now look at the class myThread. The class myThread extends the class thread and we have an instance variable L of type reintrent_lock. The instance variable L of class myThread has been initialized by the value provided by the thread main. In the method run, we are printing the name of the current thread and then we are printing trying for the lock. We know that all the created threads here will execute this statement and they will print like T1 trying for the lock, T2 trying for the lock, like that. Then after, we are calling the method lock by using the reference variable L. The thread which gets the lock will execute this statement. The name of the thread got the lock. Then after, the thread will sleep for half seconds for 5 times from I is equal to 0 to I is equal to 4. After that, the thread which got the lock prints the name of the thread dash the value of I. The current value of I means from 0 to 4. In between, since all the threads are executing simultaneously, then in between, whenever the thread main will get a chance to execute on the CPU, every time it will check that if queue is filled with some threads or not. If it is there, then the thread main will print IM main is some threads waiting. Then this method call l.getQueueLength will print the number of threads currently waiting in the queue. After executing this statement, the thread which got the lock will unlock the lock and another thread will get a chance for the lock. Finally, the thread which unlocks the lock will print the name of the thread releases the lock. Let me execute this code practically. Open check.java and this is the same code as we have seen. Open mythread.java and this is the same code as we have seen. Try to compile these two codes, Java C, mythread.java, check.java. Compiles fine. Now run it. Java check. It runs fine Let the program to finish its execution, then we will check the output. The program finished its execution, now check the output. Here all the threads are waiting for the lock except the T7. T7 got the lock. In this statement, the thread main is printing I am main, is some thread waiting, and this statement is printing number of threads which are waiting for the lock. The thread T7 started executing the for loop and number of threads waiting for the lock has been increased to 14. Up to here, the thread T7 completed its execution and the thread T2 got the lock. Now waiting threads for the lock is 13. After T2 finished its execution, T6 got the lock and the number of threads waiting for the lock is 12 now. Similarly, if you come down, then the number of threads waiting for the lock is decreasing and all the threads are getting the chance to execute the for loop one by one. The last thread to execute the for loop is the thread 14, and before to that the number of waiting threads for the lock was just 1. Only the thread 14 was waiting for the lock, and as we have already seen that the statement is getting printed only if l.hasQueued threads returns true. Means if no one is waiting for the thread, then this method will return false. So I hope you got all my points. That's all for this video guys. Don't forget to like and share this video, subscribe my channel on YouTube, like my page on Facebook, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.